Okay, so the first couple of things we're going to talk about today is, first of all, we want to be able to calculate standard deviation. And most of you are probably going, what the heck is standard deviation? Don't worry about that. I'll make it clear to you in a minute. The next one is not just a data set, but sometimes when you get data, it's in groups, and you don't actually have the original data. So how would you do this if somebody just gave it to you, for example, like maybe it was heights of people, and it was like 5'10" to 6 foot. You don't know what the data was in there. You just have a category. So we'll talk about how to reconstruct it there. It's pretty simple. But first question for you. Does anybody know who John Bollinger is? I think I'm pronouncing his name right. I kind of doubt it. I mean, he's a pretty specialized guy, but anyways, he's very, very rich. And I'll show you one of the theories he has that ties nicely to standard deviation. So first of all, let me just switch us up here. I mentioned when we started our course that math's not necessarily about numbers, but it's trying to make decisions about things which normally don't have a yes or no answer. So one thing that's out there that people really like is making money. And one place where you can make and lose a lot of money is the stock market. And so people are trying to figure out, and there's a whole field of this, how do you take what the stock is doing and figure out if it's a good time to buy it or sell it. So let me see here. Why don't we start with Apple Computer, since most of you are familiar with it. And so you might say to yourself, well, here's a picture of Apple Computer. Should you buy this stock? Well, how many people like Apple enough that you'd say, yeah, I should buy some Apple stock? That's sometimes a good way to base your decision, is just, I really like this company. But usually you want to go a little further. And so I'm just going to show you one way, and again, it'll connect with what we're doing today in the lesson. And that's to look at something like a chart. And again, this doesn't cover any kind of complete investment advice or you know, obviously if that's something you want to study in business later in life, that's great. But this is sort of just a quick one way of doing things. So you look at this and you might say, I don't know, maybe, can anybody think of a reason why you should not buy Apple right now? Yeah, Francis. Too expensive. How can you tell just by looking at the picture? It's going up. So does anybody, you know what the most famous advice in buying and selling stocks is? Buy low, sell high. Simple, right? Anyone can make money. You just got to buy low and sell high. So you look at this chart and you might notice that, oh, well, here's where things were low, and right now it looks like things are fairly high. But it's hard to judge that because Apple could be worth $1,000 next year. So people try to do these things, and what we're going to look at is Bollinger's bands. And what it is it tries to measure how far a stock would normally move, and then it tries to figure out, based on that, how far today is it gone. So you might say today is a day when Apple moved twice as far as normal. And that might tell you, well, because it moved twice as far as normal, maybe this went too far and it's going to come back down. Or maybe it's going to come back up because it dropped so far. So let me show you in a picture, because the pictures are where things kind of work out. So here's the way that, this is the advice that John gives people when he talks about buying and selling stocks. So see right here where it would have just touched the bottom band? That would mean that bottom band is 2 standard deviations below what it normally would move. So basically, this is John's way of saying, that's too far down. People have panicked. They're selling the stock without enough good reason. So because it's hit the bottom of the band, he expects it to then come back up. Price is too low right now. So it hits the bottom there, and then it makes its way for a handsome profit somewhere around there. So, I mean, you can guess that's probably about 350. And where we started was probably about, I don't know, 310. So you made about maybe even 320. So you made about $30 a share. So depending on how much you invested, that could be a good thing. You'll notice, though, that it's not perfect. Obviously, if it was, we'd all be rich. But here, it does fall like John says it would because it touched the top one, meaning it's moved too high too quickly. But it didn't actually touch the bottom before going up. So you lost a little bit. But again, you can see this part here, John would have said, no, it's getting too expensive, sell it, and then it drops back down. And most recently, you can see, here's Apple hitting the bottom one, where John would say, it has now moved too far from the normal movement, so it's going to go back up. And he would have been very right. That would have been a good one. That would have been a vacation somewhere nice, like Hawaii probably, or Vegas. So let's see here, 320 to 400. So you made about 80 bucks a share. But that's one example of where what we're doing today is actually used in the real world. And one example of, potentially you may want to look into it and see a little bit more behind the math. But I just picked Apple. You could look at just about any stock and you'll find that that pattern works sometimes for John's technical indicator for Bollinger Bands. Okay. So what we're going to look at today, though, is this idea, and I'll tell you what standard deviation measures right now. So standard deviation is a way of telling how spread out your data set is. And for example, just to get you thinking about it, if you found out that there was a diet pill, and here's the results from people taking this diet pill for 10 days. So remember, there are lies, damn lies, and statistics. Right? Here's a way that companies try to fool you in marketing their junk, their stuff they're selling, right? So this first pill, number 1, here's the weight loss over those first 10 days, and it averages 6 pounds. Here's the weight loss for pill number 2. It also averages 6 pounds. Now, the question is, well, first of all, you can ask, the companies have to be willing to provide the full results, but on the commercial, it's only going to say, people who took our pill lost 6 pounds in 10 days. And you'll go, wow, that sounds great. I'm going to buy that. And which one do you think you'd rather buy? They have the same amount of weight loss in those 10 days. Which one do you think? The first one? How come?
Because for the second one, there's a few people that didn't.
A few people didn't have any? Okay. What else? Any other thoughts? Anybody want to just gamble and take the second one? Say, yeah, I'm either going to do way better or none at all. Yeah, Paul? Yeah.
The second pill, it looks like somebody kind of fumbled around with the numbers.
Oh, okay, it looks like someone fumbled around with the numbers. But remember, the point here is you don't normally get to see those numbers. You just hear that the average is 6. So the standard deviation of these two sets would be very different. This one here, this pill number 2, would have a very large standard deviation because the middle number is 6 and everyone is far away from 6. So standard deviation is telling you it'll be big because everyone is far away from the average. Whereas pill number 1, the standard deviation would be very small because everybody is close to the average number of 6. Okay? So in reality, if you could pick one, pick pill number 1 because that means just about everybody loses 6 pounds. But pill number 2, the problem would be that, well, how do you know that these people here aren't athletes that were out of training for the summer and that this company conveniently chose September as the time to test them because now they got to get back into shape? Or that, these people here forgot to take it, or, something went wrong. But regardless, if that was your goal, was to take the diet pill, you'd want one with a small standard deviation because then it's likely to work for you as well. Okay, but sometimes we don't want a small standard deviation. Sometimes we'd want a large one. So think about it this way too. 2 polls are conducted to determine if Canadians would support taxes to pay for improvements in Medicare. So here's the results of the poll and the ages of the people. Okay, so for example, let's just say that the average age is 50 here, and the average age is 50 in poll number 2 as well. But what do you think? Which poll do you think is going to give us a better picture of what Canadians think about raising money or raising taxes for Medicare? How come? Poll number 1 is more diverse, right? So that's a good thing, right? Because obviously if you're a politician and you say, I need some data that says that my voters are going to want to pay for Medicare, well, what voters are you going to ask? You're going to ask the older ones who are going to need Medicare, right? When you're young, you don't really need that much. Like, when was the last time you actually needed to go and, have a prescription filled, or, if you think about it compared to, say, your grandparents, you probably don't use the Medicare system nearly as much, so it might not be nearly as important. Fortunately, in Canada, everybody tends to think that Medicare is important, so I'm sure that they feel similarly. But the point is, this set of data for number 2 is not very good because it does not cover a lot of people. So poll number 1 would be preferred for that reason because it's got more diverse and that would mean a larger standard deviation. Okay? So, how are we going to, how do we then figure out how data is going to be spread out? Well, let me just shrink this a little. So first of all, we have to figure out, if we're talking about standard deviation, how spread out your data is. Well, then we're talking about how far away you are from the middle. Okay, so that's how we could describe it. How far are you from the average? So this formula here is not going to mean much, but I'll show it to you, and we'll talk about how it works. I'll give you the formula, but it's easier if you just see an example of how to work it. So standard deviation, first of all, what we have to do, there's a problem with just taking the distance for averages. Because, for example, if we had this data set here, and the average is 6, okay, then if I looked at the differences, the difference here is -1, +1, -2, +2, -3, +3. And if I was just to take those differences the way they are, whoops, what's going to happen when I add them all up? You get 0. So this would say, hey, this data set, everyone's exactly the same. There's no movement. Everybody's standard deviation is 0. So we can't just take the distance. What we're going to do instead is we're going to be sneaky about it. We're going to take that number and square it, because that way, if you have a negative number, when you square it, it would turn positive. So that's what happens right here in that formula. This piece is the distance and we're going to square each number. Okay, that way, again, like I said, it's going to become positive. And this is the number of items. So if we found out that we added these all together, and there was, I don't know, let's say the number was 26. There's 13 items, so that means there's an average of 2. So we're dividing it out. And then finally, we're going to undo that square. So I don't expect you to, I mean, you can work with the formula, but I'll show you it's a little easier if we just do an example on a table, and this is what you're going to be doing for your homework. But that's kind of where the formula comes from. We can't just do the difference because some would be negative, so we got to square it. Let's see here. So for now, I'm going to pause for a second, and we're going to take a little poll and see what the standard deviation is for how many movies you've seen in the last 30 days. Okay, so what I need you to do is take your iPads out, and this is where you're going to go to show us. So go to Foundations Math and go to Standard Deviation. You can vote on both polls while you're there, because we are going to talk about data from both of them. But the first one is, how many movies do you see either on the theater or on TV in the last 30 days? Okay, so I'm going to take a look at the results. And then we'll transfer it over. Wow, there's some people who watch a lot of movies. Okay, so I'm going to copy this data, and that's what you need to do with me so that we can all practice together how it works. So no movies got 3 votes. One movie had 3, then 4, 5, 6, 10. And let's see here. 4, 0, 1, 1. And 3 people that watch a lot of movies. So now that we know, this should be familiar from last time, right? We should know how to do the frequency table and build it up like this. So I'll let you just copy it in, and then I'll show you how we do the next calculation, that standard deviation. Okay, so I'm going to show you how we calculate the average here. Because I've got my data and a frequency, what I can actually do here is, instead of counting up every single one, I'm just going to put this in as 0 times 3, 1 times 3, 2 times 4. And this way, I don't have to add, I can use that bit of multiplying to speed up this adding together my values. Okay, so I'll let you do that. And of course, you've got a calculator on your iPad. So one of your partners there can do the calculation. I'll do it as well. So if you're still working at it, I get a number of 171. Okay. And the number of people that answered this, let me just count it up quick here. 31, 35, 36, 37, 40. So the average will be 171 divided by 40. So that's going to be about 4.275 movies. So now what we want to do is figure out, now that we know what the average is, we're going to figure out how far everyone is from the average. Right? We're starting to calculate this distance. So I'm going to start filling them into this column here, this deviation one. So for example, in the first one, how far is 0 from 4.275? How far is 1 from 4.275? And we're just going to do this all the way down. So I'm going to come back and put the answers in there for you, but you're welcome to use your calculator as well. But for now, I'm going to fill them in, and I'll pause our video. Okay, so there are the, that's how far away you are from the middle. That's the deviation for each piece of data. But remember, what's the problem with adding in all up the way it is now and using that for our measurement? What could go wrong? We just added it up now. There's a problem. Yeah, Frank. Yeah, it did, but if you put it in your calculator, 5 minus 4.275, 0.725 is left over. So those numbers, I believe, are correct. So again, the problem with taking it the way it is that if you add those numbers up, some are positive, some are negative, those distances are going to shrink when really we're not interested in positive and negative. We just want to know how far away they are. So what we do to get around the negatives is that we square everything. So everybody gets their distance squared. So that's what we're going to add in that next column there, is now that we know how far apart everyone is, let's find out their distance squared. So I'm just going to use my calculator and square each of those data points. Okay, so again, I'm just trying to help you walk through the process, so I'm going to recap for you. Standard deviation is how far away you are from the average. So the first thing we need to know is, what's the average? Once we know the average, we have to find out how far away each person is from the average. But there's a problem, because negative distances and positives would make things cancel out. So we square everybody, so everyone's positive. And that's the spot where we're at right now. Okay, so you should have, if you squared each of them, this would be the set of numbers that you get. And the last thing that we need to do, and then we'll be finished with it, is how many times did this distance of 18.28 occur? How many times were people that far away? Well, it happened 3 times. So if we're to add everything up, that means we're not adding it properly unless we add it by the number of times it showed up in the data. So same thing for this, for 1 movie a month. That means 3 people saw it. So this distance of 10.73, that would have showed up in 3 people in our data set. So that's what this timesing by the frequency is for the last one. Okay, so I'll fill in those numbers with you. All I'm doing again is I'm taking this number here and I'm multiplying it by how far away it is. This number here, multiplying it by how far away it is. So I'll say it again, because I know this is the toughest thing we've done so far. It's probably one of the toughest things we'll do in this unit as far as thinking about the set of steps. So again, what is standard deviation? It's about how far away you are from the middle, how much you deviate. So first we got to know what the middle is. That's the average. Then we got to figure out how far each person is from that middle point. And that's this first step here. How far away is everyone from the middle? Then we can't let negatives mess up our data, so we squared everybody. Now that we have all the distances, we need to know how many times they showed up in the data. That's here. So now I have all my distances for everybody that's in the data set. So now the last thing that's left to do is add them all up, and we'll divide it by the total number of people, which is 40, and square root it. So I'll show you those last steps here for standard deviation. The total, okay, so the total that I ended up getting was, let's see here.
I know, I wish you sent it yesterday though. Yeah.
Let's just keep 2 decimals. So that's the total if I added them all up. So to calculate standard deviation now, this is of everyone. So what we're going to do is we're going to bring it back now in terms of each piece of data. So I'm going to go 268.14 and say, how much does that mean out of all the 40 pieces of data, how much do they all get? So if I divided it by 40, each piece would have 6.70. But there's a problem though, because that's not the distance, that's the distance squared, right? We squared those distances. So now what I'm going to need to do is take the square root in order to figure out what that standard deviation actually is. So for this data set, it's 2.59. Now, first of all, let me put some of your fears to rest. If I asked you to do this on a test, I promise you I will give you like maybe 5 points to do it on, right? I don't want to take up half an hour of your time to do one of them, but I wanted to walk through one in enough detail with you that we could talk about it together, okay? So as far as the length and the duration that it took here, you know, if I'm asking you to do it for an assignment, something like that, I will try to keep it down to something more manageable. Now, if we took a look at the second question, did everybody have a chance to vote on how much they spend on lunch? Let's see here. Not yet. A couple people. Okay, so that's going to be enough for us to talk about it. So I'll just, for now, all I want you to do is just, we'll gather up some data like we would have done, but then we'll talk about strategies to make this second part go quicker. So for the first one, 15 people were in this group. Then it went 5, 3, 5, 3, 2, 3. Okay. So what's the problem with this data compared to the old data? There's what? There is a lot, but there's a problem here. You have to think about this data. What's the difference between this and the last one that we looked at?
There's a range.
There's a range. So I don't actually know what the numbers were that people spent on lunch. Like, it wouldn't be practical for me to put this out in pennies because there'd be like so many values. So sometimes if you get your data in a range, how do you think we could make a good estimate so that we could actually do this again? Paul, yeah, you got a suggestion? Yeah, we're just going to use the middle of everybody. So we'll say, I don't know if it was $0 or $4, but I'm going to guess that it was $2. I don't know if these people in the next column spent $4 or $8, but I'm going to just say, well, they probably spent about 6. They probably spent about 10. They probably spent about 14. And these would be the values that I can use for the data now. Okay? So if we forget the originals, we would just toss these ones out. And we'd say, these are the numbers I'm going to use because that's the best I can do to reconstruct my standard deviation. You don't have the original data, so it's not going to be perfect, but it should give you some close estimate. Okay? So we won't go through the whole calculation a second time, but if you're faced with a range of values, that's how you're going to have to do your calculation, is use the middle so that you have a data point.